Okay, hello again, Year 8, and anyone else that's decided to have a little quick look at this. This fortnight's task is focusing around equations, solving equations, and a little bit about inequalities and solving inequalities as well. So I've split it up into 4 different mini lessons on this clip, starting with making sure we understand what inverses are and solving equations using that really explicitly. Then going on to solving some basic equations, 1-step and 2-step. I'll get into that in a minute, what that is. Then starting to introduce some more difficult ones, and that's going to be to help you with lesson 3 and 4, which involves solving with x on both sides, but also solving with fractions involved. And then finally, lesson 5 and 6. 5 looks at an introduction to inequalities. That's quite nice and basic, but just making sure you understand the difference of these signs. And then going on to lesson 6, where we're actually solving with inequalities and looking at what the difference between solving with inequalities and solving with equations is. Okay, so lesson 1. All right, so I'll scroll down to that bit in a second. So first of all, inverses. Now, I want to make sure, first of all, that we know that inverses basically just mean the opposite to it. It's what undoes something. Okay, so if I was to add 3, I'd have to subtract 3 to reverse that. So add and subtract are inverse. That also means if I was to subtract 3, I'd have to add 3 to reverse it. So these are a pair. And then I'm sure you worked out that multiply and divide would also be inverse of each other. So if a question says what's the inverse of subtract, would be to add. Now this is really just to get you started into using inverses with solving equations. Okay, you've also got square and square root are inverse to each other. Cube and cube root are inverse to each other. Some people think square and cubes are inverse. They're similar sort of stuff, but they're not opposite to each other. If you were to square 4, I couldn't get back from 16 to 4 by cubing it. Right, this bit here, 3x is 18. So this is just like the first worksheet you've got, just to make sure you're really confident with this inverse stuff and using them in function machines. If I've got 3x equals 18, that means that if I had x, I'd have to multiply that by 3 to get 18. So I'm going to use the inverse to undo that, which means I'm going to start with 18, and opposite to multiply is divide by 3, which gives me 6. So that's x equals 6. Now, I wouldn't expect you to do all this sort of working for a standard question, but for, showing, you could get a question with function machines in your exams. You need to understand it still. The next lesson, okay, let's get that a bit nicer. The next lesson is all to do with solving equations, okay? So these ones here, these two here, I'm quite happy for you to just do it in your head, basically. Think to yourself, either 5 times what is 20, okay, and getting 4, or x times 5 is 20, so I do the opposite, divide 20 by 5 to get x is 4 again. This one, let's get rid of that plus 8 by taking 8, so x equals 4. Now, you don't need all this working for just a 1-step equation, but these next 2, you will need it. Okay, if you don't show your working from these, you may well lose marks in the exam, so it's best to make sure you do. So I've got 3x plus 5. Now that 3 is pretty attached. You can see it's pretty attached. And if I was to start with x, I would times by 3 first and then add 5. So we do the opposite things in the opposite order. We take 5. That was the last thing we did. We had 3 times it plus 5. So the last thing we did was plus 5, so we need to take 5 to get rid of it. I'm going to do the same to both sides to keep it a balanced equation. That means that this goes and you're left with 3x on the left, and on this side you're just left with 21. Once we've got there, I think you can see divide by 3, x equals 7. The next one, a little bit harder still, because actually this is going to involve a negative. If I take 9 from both sides, a lot of people go, oh, 5 take 9, that's 4. Think about it. Slow yourself down. 5 take away 9 is actually minus 4. So we've got 4x equals minus 4 because that cancels. So x, divide that by 4, minus 1. And finally, it's not just negatives you can have, you could also have some horrible fractions sometimes. To get rid of that 5, we divide by 5. Remember, you're always going to be dividing by whatever that is. If it's 5x, 3x, 10x, whatever, it means you do the same to this side. And 1 divided by 5 is a fifth, or 0.2. I'll accept either of those, but I'm just going to leave it as a fifth. Okay? Next one. Lessons 3 and 4 now. So, solving more difficult equations here. These first 3 are all where you've got x's on both sides. Okay, and they get slightly more difficult as basically a few more negatives are introduced as we get nearer the bottom. Okay, so this one, you've got x on both sides. You can't solve it straight away. We need to make it look like more like what we had on that last lesson. We've just got an x on one side. So if you've got an x on both sides, you're going to look at both the x's, and my top tip here is get rid of the smaller x. In that case, that involves just taking it away, because this is a positive x. We could see this. I would recommend thinking that it's just 1x. We're going to take 1x from that side. We're going to take 1x from that side. It leaves us with 2x plus 5 equals, that goes, 13. Now, this here looks just like the page before. Okay, that's just now a two-step equation, basic equation to solve. Take 5 from both sides, 2x equals x. Divide them both by 2. X is 4. Next one. X over here, x over here. What's smaller, 4 or minus 2? Minus 2 is, of course, smaller. A negative will always be smaller than a positive. So how do you get rid of a negative 2? You would add 2x. That's where people really struggle, because you've got to realise when it's a negative, you need to add to get rid of it. So we're left on this side with 6x minus 3 equals, that goes, 21. Add 3 to both sides, we have that, and then divide both sides by 6. X is 4. Now, what's going to be smaller out of minus 3x and minus 5? Well, the bigger the number, the 5, actually, when it's got a negative in front, it actually makes it smaller. So negative 5 is the smallest. We're going to add 5x to both sides. Now, basically, our method is making sure that it will always be a positive x. It just makes it a bit easier for us. So I'm going to add 5x to there. I get minus 3 plus 5, takes us all the way up to 2. That stays as 11. That goes. That's 19. Take 11 off both sides. You get 2x equals 8. So x equals 4. Okay. Last question. All right. If you've got something like this where you've got fractions involved, that's even worse than having x on both sides. That makes it even harder. So we want to get rid of that straight away. So to get rid of divide by 3, there's a few different ways that you could do it. You could multiply this side by 3, and then you do it. It can get quite complicated. And one of my students, I think, just went through their method with me the other day, and I thought, you know what, that is that does seem like a lot more sense. So I'm going to try it their way. All right. Whatever this number is here, whatever this number, I'm going to try and make them the same, because then they can cancel out. So I'm going to actually times this side by 3 and this side by 5. But whatever you do to the bottom, you've got to do to the top. So on the top of this side, I've got 3 lots of x plus 4, which is 3x plus 12. And on the bottom, 5 3s are 15. On the top, I've got 5 lots of x plus 2. Careful, a lot of people tempted to write 5x plus 2. Don't forget you've got to times that 2 by 5 as well. And again, on the bottom, 3 times 5, 15. Now, because I've got out of 15 on the bottom, I could just times everything by 15. It cancels them out. Okay? And at this point now, I can take 3x off both sides. So it's not got that divide line at all now. It's completely gone. And that leaves me with 12 equals 2x plus 10. Take 10 off both sides. 2 equals 2x. So 1 equals x, but obviously we'd write that x equals 1. Okay. That would actually get you full marks though, but we just like to write like that. Okay, and very lastly, inequalities. We just need to make sure you know what these things mean. So this one means that this side here, so let's say 8, is more than 6. So we often see that as more than, but that's because we read from left to right. It also technically means 6 is smaller than 8. Basically, it always points, the arrow always points at the smaller one. you might have heard that the crocodile opens its mouth to the bigger number. Okay, there we go. It's an amazing drawing of a crocodile. And it's hungry, it's greedy crocodile, so it always eats the biggest. So it always opens its mouth to the biggest, but it's also pointing to the smallest. Whichever way you want to learn it, that's up to you. This then means that this side is less than that. And if it's got this little bit here on the bottom, that just means it could be equal to as well. So 10 is bigger than or equal to 8, or 5 is smaller than or equal to 5 technically, because they could be the same. Okay, now we've got some solving. Now I just want to make sure that there's two clear different types here. Let's just do it for this one to start with. We have got 3x plus 2 is bigger than or equal to x plus 8. Now what I want you to do in almost every case is just treat it the same as you would any solving equation. The only difference is rather than write equals, you write whatever sign this is. There are some exceptions which I'll get onto in a minute. So if I'd make that 1, I would then take away 1x from both sides, which would leave me with here 2x plus 2. Keep the sign, that goes, plus 8, so just 8. Then I take 2 from both sides. 2x is bigger than or equal to 6. Then divide both sides by 2, giving me x is bigger than or equal to 3. And that is my answer. It hasn't changed at all, apart from that is the same as that rather than equals. And for most of the cases that'll work. The only time it won't is either when you've got a negative. If you have to divide something by a negative, so I'm dividing that by negative 2 to get rid of it, you have to flip that sign around. And if you think about it, 4 is bigger than 3. If I double them, 8 is bigger than 6. If I add 5 to both of them, 9 is bigger than 8. If I take 2, 2 is bigger than 1. If I add a negative, like add negative 3, 1 is bigger than 0. All those things, if I square them both, whatever, they'll always stay that this one's bigger. Unless, if I times or I divide by a negative number, so let's say times them both by minus 2, okay, so I was going to use that for now, would be minus 8 is bigger than minus 6, and that is not true. Minus 8 is smaller. So if you multiply or divide by negative, you've got to flip the sign. That means dividing by negative 2 gets rid of that. I'm left with x. That would be minus 5, so x is bigger than minus 5. And the only other time that you need to do that is if you've got an answer of 10 is smaller than x, if you just flip them round, obviously if you had 10 equals x, and you flip them round, x equals 10, fine, happy days. But if you flip these around, you've got to change the sign as well, because if 10 is smaller than x, x is bigger than 10. So if you move the x round, or if you times or divide by a negative, then you flip the sign. If the sign was less than or equal, it becomes more than or equal. You just flip the direction. Okay, I hope that helps. Any questions, please do comment on your homework and I'll help you out with it. All right, look after yourselves. Bye.